So 8th graders, it's Mrs. Thompson. We're getting ready to start 4.8, and I think you're going to really like this section. It's heavy calculator driven. I think everything in the chapter in this section, except for example 1, are heavy calculator. And I'll be setting up the camera so you can watch my keying sequence and the later examples. You're not really going to have to see too much of the keying at the moment, not for example 1. So let's look at our objective. We're going to determine the line of best fit for a set of linear data, and then we're going to determine and interpret the correlation coefficient. That will be later on, subsequent examples. And let me just tell you what a line of best fit is. It's the trend line for a set of data, and it models that data. And as you can see down here in example 1, I'm showing you 2 trend lines. There's a red one that's here and a blue one. And we're going to be tracking those and figuring out what's going better. Now, some trend lines fit a data set better than others. And we're going to evaluate how well that line fits. And we're going to use something called a residual. Now, look in your notes here. A residual is the signed vertical distance between the data point and the line of fit that you're tracking. So the closer the sum of the squared residuals is to 0, the better the line fits the data. Let me read that again. The closer to 0 the sum of the squared residuals is, the better the line fits the data. Okay? I'm going to show you exactly what that looks like in example 1. We're going to calculate residuals, and the data in the table are graphed along with 2 lines of fit. For each line, we're going to find the sum of the squares of the residuals, and then we're going to determine which line is the better fit. So that's our goal for today. Now what I'm going to do is, because that first line is in red, I'm going to write everything in red, okay? I'm going to color code it, and then I'll go back and we'll calculate the residuals in blue, okay? So hopefully that makes sense. So let's focus on that first line, which is y equals 0.5x plus 3. If you don't know where I got that, out here is the name of that line out to the side. I did it for each line. So the red line is y equals 1/2 x plus 3. And the blue line is y equals 1/2 x plus 2. All right, now to calculate residuals, there are 4 points. Here's 2, 6. 6, 7, 4, 3, and 8, 5. And what we're going to do is we're going to count how far away from the red line they are vertically. Okay, not at an angle, straight up and down. Okay, so 2, 6 is 1, 2 units away. So we're going to write 2 squared plus. Okay, let's go over to 6, 7. 6, 7 is 1 unit away, so write 1 squared and then a plus sign. Let's go to 4, 3. 4, 3 is 1, 2 units away, so that's 2 squared. And 8, 5 is 1, 2 units away. Okay? That vertical distance is what we call a residual. It's the distance away from the trend line. And we're going to square each of those numbers and add them all up and see what their sum is, okay? So we have 4 plus 1 plus 4 plus 4, and it looks like we have 13, okay? So that's for the red line. All right, now I'm going to switch colors to blue, and now we're going to track y equals 1/2 x plus 2. Now we're going to focus on how far each point is away from the blue line this time. So ignore the red line and focus on the blue line, which is y equals 1/2 x plus 2. So let's start with 2, 6, and I'm going to ignore them, but go right past and see how I went down 3 units. So that's going to be 3 squared. Now let's go to 6, 7. Let's go down 1, 2 units. That's going to be 2 squared. Let's go to 4, 3. Hey, I'm only 1 unit away with 4, 3. And then 8, 5 is only 1 unit away. Okay. Now, what I calculated, what I counted was the vertical distance, the residual, how far away was each point vertically from the blue line. And so I counted the boxes, okay? And then you go back and you square each one and then add them up. So I have 9 plus 4 plus 1 plus 1. Well, that looks like 15, okay? Now, we have the sum of the squared residuals for our red line. We have the sum of the square of the residuals for our blue line. And now we're ready to make the determination. Which line's the better fit? The way you do that is you look at the number. The smaller the number, that's the better fit. Or the number closer to 0, however you want to look at it. The number closer to 0 or the smaller number is the line of best fit. And so in this case, the better fit is the red line, which is y equals 0.5x plus 3, because it's the square of its residuals. The sum of the squared residuals is 13, whereas the blue line's sum is 15. 13 is smaller than 15. 13 is closer to 0 than 15. Therefore, the red line is the better fit. Okay? Write down your questions about this. If you're not really sure what I just did, rewind me, watch it again, and see if you can pick up what I just did here. I hope this is actually very easy for you. Please bring your questions to class.